Okay, so let's talk about solving problems where we have more than one object. In this particular problem, we have two objects. They are connected by a string. They are being pulled by a force on the first object, object A. And when they move, since there's a string or a wire connecting the two objects, that tension is going to obviously pull on mass B or object B. And the idea here is when you pull them, if there's enough force, they're going to accelerate. And they are going to accelerate together. And at any given instantaneous moment, they're going to have the same acceleration. Well, we're going to assume acceleration is constant anyway, but they'll also have at that instantaneous moment the same velocity. A and B have to travel together in the same way. We are going to we have to have them accelerate at the same rate. We have to have them having the same speed at the same instant. Otherwise, A would start to pull away from B, and we don't want that to happen. Or they would travel and B would start getting away and smashing into A. We don't want that to happen either. So we assume that they travel in the same exact way. That makes sense. In this first example, we're going to assume that there's no friction to make it easier, and then we'll get into a friction problem towards the end. Lastly, for this class, when we do problems, we're going to assume that any pulling force is horizontal or along an axis, pure X or pure Y. We're not going to do any pulling forces. We're not going to do any pulling forces at an angle. So we're not going to do that. We're not going to do that at all. So that makes our lives a bit easier when we're solving these problems. So the first approach, is to treat possibly, if we can, the first approach is to treat the objects together as one overall mass. Because if we have two masses being pulled by a string, but there's only the pulling force on the first mass, and we know the masses are going to travel together, well, can't we just say, well, we're going to combine the system, right? We're going to say, well, we're pulling both masses, and analyze it that way. And with any situation, you're going to do a free body diagram. We're going to have the force pulling of 10.0 newtons. And we're going to have a normal force. And that normal force is going to be of A and B on the ground. We're going to have the gravitation. And that's going to be the gravitation of A and B combined. And we're not going to have any backwards force because we assumed no friction here. And that's pretty easy to analyze then, because all you have to do is say, well, summation of the forces in the x direction equal ma. And the only force in the x direction, and again we have to know our coordinate system, right? So we can assume that positive x is to the right and positive y is upward. And so our pushing force or our pulling force is F, and that's going to equal our total mass. Well, our total mass is ma plus mb, right? We have both masses acting together, and we have the acceleration of the system. And we know all this information. We can just plug it in. We know that the force is 10.0, and we know that the masses are going to be, 1.0 plus 2.0, and we can find the acceleration of the system, 3.33 meters per second squared. That's pretty easy, right? No big deal.